So just to give you, again, that example, if I take the cycloid for a wheel of radius 1, and let's say that we are going at unit speed, so that the angle that we used as a parameter last time is the same thing as time. Okay, so then the position vector, in this case, we found to be, just to make sure that I have it right, t minus sine t and cosine t. No, 1 minus cosine t. Okay, same. That's a formula that you should have in your notes from last time, except we had theta instead of t because we were using the angle. But now I'm saying we're moving at unit speed, so time and angle are the same thing. Okay. So, okay. So now, what's interesting about this is we can analyze the motion in more detail. Okay. So now that we know the position of a point as a function of time, we can try to study how it varies, and in particular things like the speed and the acceleration. Okay, so let's start with speed. Well, so in fact we can do better than speed. Let's not start with speed. So speed is a number. It tells you how fast you're going, along your trajectory. I mean, if you're driving in a car, then, it tells you how fast you're going. But unless you have one of these fancy cars with a GPS, it doesn't tell you in which direction you're going. And that's useful information, too, if you're trying to figure out what your trajectory is. So, in fact, there's two aspects to it. One is how fast you're going, and the other is in what direction you're going. That means, actually, we should use a vector, maybe, to think about this. And so that's called the velocity vector. And the way we can get it, so it's called usually v. So v here stands for velocity more than for vector. And you just get it by taking the derivative of the position vector with respect to time. Okay, now it's our first time writing this kind of thing with a vector. So the basic rule is you can take the derivative of a vector quantity just by taking the derivatives of each component. Okay, so that's just dx dt, dy dt, and if you have a z component, dz dt. So let me. Okay. So. Okay, so let's see what it is for the cycloid. So in the example of a cycloid, well, so what do we get when we take the derivative of this formula up there? Well, so the derivative of t is 1 minus cosine t. The derivative of 1 is 0. The derivative of minus cosine t is sine t. Very good. Okay. That's at least one thing you should remember from single variable calculus. Hopefully you remember even more than that. Okay, so that's the velocity vector. It tells us at any time how fast we are going and in what direction. So, for example, observe, remember last time at the end of class, we were trying to figure out what exactly happens near the bottom point, when we have this motion that seems to stop and go backwards. And we answered that one way, but let's try to understand it in terms of velocity. Well, if I plug t equals 0 in here, then 1 minus cosine t is 0, sine t is 0, the velocity is 0. So at that time, at that particular time, our point is actually not moving. Of course, it's been moving just before and it starts moving just afterwards. It's just, the instant, at that particular instant, the speed is 0. So that's a slightly maybe counterintuitive thing, that something is moving and at that time it's actually stopped.